This video is about limiting reactant. So we have a balanced equation, 2AgNO3 plus MgCl2 yields 2AgCl plus MgNO3 2. We start with 55.9 grams of AgNO3 and 80 grams of MgCl2. They're mixed in solution and they react. So we're eventually going to figure out how much of the product, which is AgCl2, how much of that are we going to make in grams? Well, we have two different amounts of reactants, AgNO3 and MgCl2. And we're going to need to figure out which one gets all the way used up. That's called the limiting reactant. And that's what we'll use to determine how much stuff is going to be made. There are a couple ways to approach this problem. One is to take both of your reactants, take the amounts, figure out how much product can be made, and then pick the one that makes less, and that's how much you make. But another way is to find the moles of the stuff you have and compare them. And that's what I'm going to do. Okay, so I'm going to start with 55.9 grams of AgNO3. I'm going to drag down my grams AgNO3 and convert that to moles. I look on the periodic table, add up 1 silver, 1 nitrogen, and 3 oxygens, and find the number of grams in a mole. And that number of grams for silver nitrate is 169.87 grams in 1 mole. Top times top, divide by bottom, and that's going to give me 0.329 moles of AgNO3. So now I'm going to find the moles of MgCl2. So I take my amount, 80 grams MgCl2, and that's for MgCl2 there. I'm going to drag down grams MgCl2 and go to moles. Look on the periodic table, 1 magnesium, 2 chlorines. 1 mole of MgCl2 is equal to 95.211 grams. Top times top, divide by bottom, and we get 0.840 moles MgCl2. Now, what you do with this information to find the limiting reactant, it's not just always the one where there are fewer number of moles. Because of the balanced equation and those stoichiometric ratios. So it could be, and it's not for this equation, but it could be that for 1 mole of AgNO3 or 2 moles AgNO3, you could need 15 moles of MgCl2. So you could have a lot more MgCl2 and it still be the limiting reactant. So check your moles, check your amount for each of them, and we're going to figure out if we had, so this balanced equation, for this balanced equation, if we had this much AgNO3, how much MgCl2 would we need to totally react it? Okay, so we start with 0.329 moles AgNO3. Drag down moles AgNO3. And we're going to go to moles MgCl2. Check the balanced equation, that's 2 and 1. Punch that in your calculator, and what you get is 0.165 moles MgCl2. And what this means is if all of the AgNO3 were to react, you would only need 0.165 moles MgCl2 to totally react it. Any more than the 0.165 moles is going to be extra. So we have 0.84 moles MgCl2. We're going to have extra because you only need 0.165 moles to get rid of all your silver nitrate. So because of that, you have extra MgCl2. All your AgNO3 is going to get used up, so that is the limiting reactant. So AgNO3 is limiting. Now we're going to figure out how much stuff we're going to make. How many grams AgCl? We're only going to use the amount of AgNO3 to start with. We're not going to add the MgCl2 into it. We're just going to use AgCl. All right, so we're going to use our number moles, 0.329 moles AgNO3, and we're going to get to grams AgCl. I'm going to erase some of this over here for space. All right, I'm going to drag down mole AgNO3. I can convert to mole AgCl, and drag down mole AgCl, and go to grams AgCl. I use my mole to mole ratio from the balanced equation. And so for the mole to mole column, I'll plug in that mole ratio. Again, notice I'm not adding in MgCl2 anywhere, just solving using AgNO3. Okay, so for mole to mole ratio, got 2 and 2 from the balanced equation. Grams to moles, 1 mole has Ag plus Cl is 143.32 grams. Punch in your calculator, 0.329 times 2 times 143.32, divide by 2, divide by 1 equals. And you get 47.2 grams AgCl. So that's the amount you would make, 47.2 grams of AgCl. So remember, there are a couple ways to approach this problem. You can do what I did in this example, which is find your moles of each reactant, compare them, see which one would get used up and which one would be extra. You could also take the amount of reactants, figure out how much product you would make, and then pick whichever one is less. You're not going to add up the amount of product that each kid made. You're not going to add up the grams together. You're just going to figure out which one gets used up first. That is your limiting reactant. That's what you use to determine how much stuff is made.